Hi everybody. My name is Peter Parnes. I'm a professor in pervasive and mobile computing here at Luleå University of Technology. I'm also a distinguished university teacher and have earlier founded the Architect Learning Lab, which is a collaboration of researchers around learning with modern technologies. Um, so I'm going to dive into some of my thoughts about using computer game technologies for learning and other applications, and I'll give you a number of examples from the projects that we've been doing over the last 15 years or so there. Um, but before we dive into that, I just want to give you a bit of a background about myself, a tiny bit about myself, and that is I've been working with online meeting tools since around 1994 when I became a PhD student here at the university. I developed a system called MStar, which was one of the world's first multi-user video conferencing systems. This was commercialized as Maratech, and then Google came and bought that in 2007. I was Google's development manager for Sweden for a couple of years. We've been using sort of video conferencing tools for learning for many years, and in my opinion, it's a sort of a rather boring tool to use for learning. It's hard to engage students online using these sort of traditional tools, and I see all our modern video conferencing tools as traditional, Zoom, etc. And the other angle into this is that learning should be fun. Tools should engage in engagement, and the students should want to learn. So the idea here is, can we motivate learning through computer game technologies? That is, make learning more fun and more exciting, increase motivation for learning, and get students and pupils to practice more. So many of the projects I've been working on are targeted towards sort of compulsory school years, starting very early, as you can see in the bottom down corner here. That's Julie. I think she's about sort of 5 years old in that picture, doing a sort of a hand game together with this robot. We have some other young females here that are working with creating computer games or visualizing cities, etc. So one of the first applications I created to try out and see if it can sort of create motivation for learning was a app in 2011 for practicing multiplication. Very simple application. You just had to answer the multiplication questions, and you got a time on this, and then you could benchmark yourself against your parents, your friends, etc. And this was a rather simple application. There was no real multiplication trial application on App Store back then. So it's been sort of downloaded 250,000 times since then. It's still available, you can try it. But the conclusion there was, yes, it sort of helps young people to practice more. So there's this gamification effect. Another example is, how can we engage young children in building cities and city development? And here we had a project called Skogsstaden, Forest City, where we gathered about 200 young people to create their vision for the future of Luleå city here. So this was done together with the municipality, where we got them to sort of create and build things. So this was supposed to be the future bathing house that was then planned to be built here in Luleå. And they created many different environments like this and got into discussions with adults at the municipality, at the local energy company, etc., on sort of how should a city be developed from a young person's perspective. Another example was this. This is We Are in School, the project we did in 2016 together with a lower grade school teachers, again here in Luleå, where we provided VR equipment to the schools. And then I had a number of students develop applications based on the requests from the schools. So very iterative, a very quick process here. They wanted to have like applications for practicing spelling, math, geography, etc. And the students created prototypes for this, and they could very quickly iterate that. Another example that we also created as part of the same project was this is Math Ball, where we sort of practiced math using a sort of shooting game. You got these number tasks and you have to run around and find the right ball. Later on, we did a multi-user version of the same tool where several there, so they could basically compete on both doing the math but also on finding the answers. You had like shoot the right number balls here. Another example, this is a demonstration I made as we were revising our math education here at the university as an example of visualizing math. So here is like you can on one side of this whole you can see the more mathematical version of it, and then on the right side you could see sort of the effects from a computer graphics perspective. So if I change certain parameters in the math, the graphics changed as well. So that sort of visualized math thing or complex math, I should say. Another project we did a couple of years ago was to increase boys reading, like reading physical books. In Sweden and I think all over Europe, it's a trend that boys read books much less than females in lower grade schools. So here we created a project where the children got to create a computer game, but based on the content of the book. So meaning that if they didn't read the chapter for the next session together with the computer game creators, they couldn't really participate in creating the game. So they got sort of a motivation to read. Another example, there are many examples here. This is a protocol in Sweden called Läslust, Reading Desire. This was done with the special school here in Luleå, so for children that are mentally challenged. So they couldn't read very much, but they could sort of read together, help each other. So here we created a game where they like was a 3D environment. They had to find a journal and read the journal to be able to continue their task in this 3D world. They got various coins, etc., as a sort of gifts in the game, and this turned out to be very successful to get them engaged in actually practicing reading. And talking about people with disabilities, this is a tool that we created to help people with aphasia, both young and adult people. And aphasia, if you don't know that, that is where you have some acquired brain damage. So typically in car accidents, etc., or it might be a stroke or something. And in some cases, your brain works, but you typically can't express yourself. So, for instance, your spoken language is limited to saying yes or no and grunting various noises. So your brain works, but you can't interact with the outside world. Imagine being sort of stuck in that kind of brain. So we created a tool to help these people express themselves through avatars, through various buttons so they could form language and this sort of philosophical tree as part of that was sort of all the research. This was very successful, but some of the feedback we got was that and that they people wanted to move around like in the physical 3D world. And if in Dialogica they were sort of stuck sitting in a circle. I know. So we took this a step further and then created what we call then Walkabout. And this was a full-fledged multi-user learning environment in 3D. So it was a tool, full video conferencing, etc. And I'll give you a few snapshots of this. Walkabout is then an environment for learning in a fun way. As I said, it's multi-user. You can choose your avatar, sort of how you want to express yourself. There are built-in animations, so you can like have simple animations like raising your hand or roll around or pretending to type on a computer, etc. You can have different worlds there. And I'll just continue showing some snapshots from this environment. So these are some of the 3D worlds we had in this game or gaming environment. You have like for space, Wild Wild West, a small city here, and the bottom right was used very much because there was a lot of open space, so you could sort of continue building inside the game. So this was multi-user. You could have multiple rooms at the same time, so the users could jump between different rooms. You could have different courses in parallel and jump between them as necessary. The game also had 3D positional audio, so when you moved around in this environment, you could speak, you could use your natural voice, and depending on the distance to the one speaking, the volume would be lowered. So, and this was calculated then sort of with an exponential drop off in audio, meaning that you could overhear conversations just as sort of in natural life. You got these natural breakout rooms, sort of a group of students could just move away from there and speak by themselves. And if there sort of were an audio collision, they could just move away further away. We on purpose did not integrate real-time video into this, but rather you had this avatar express your sort of you in this world. And then to import other content, we had sort of these web screens, which is basically full-fledged Chrome browsers that you could then open up inside the world and then show anything that could be shown on a web screen. A more lightweight version of that was these post-it notes where you could just post a post-it note, type text on it, and you can see all of this is in Swedish, but we also, I'll just skip that one, but as you can see in this, or it might be a bit hard to see, we had also real-time translation in here, so you could chat. I could write in Swedish, and then if another participant had it set up in Ukraine, for instance, this would be then real-time translated to Ukraine and back, and this went for the notifications and for these nodes as well in the 3D environment. So you could sort of go over language barriers when speaking to each other. So some of the learning scenarios we had within the walkabout is sort of live lectures where you could have like students sitting around in a group listening to live lectures, or then move on to breakout groups. Students could prepare presentations so they could move around in the 3D world, find a nice spot that they liked, create, set up their own presentation environment, think of it like poster sessions, and then when with their time to present, everybody would gather at their site. And then it was used for social hangouts and sort of asking questions. So all of this was implemented and tested in several EU projects and other projects. Then we also did some more experimental features that wasn't sort of fully developed, and that is the first one is the learning companion, and that is that you had a AI-driven companion with you in this environment, and this was typically an animal. Here are the number of dogs, but it could be basically any environment from this sort of cartoonish library of characters. And it would then sort of, and the idea was really that you should sort of develop from the activity. The more I learned, it would then change the sort of narrative and help me learn more. And the other is the intelligent help bot, and this is basically a interface to a large language model where it sort of uses generative AI to answer questions. So basically another way of interacting with ChatGPT or Claude, but based on the content of the learning, what we're supposed to learn right now. So key takeaways from doing this, our experience and tests and questionnaires, etc., all showed that motivation went up when using these types of gamified environments. So, and we know that games tap into intrinsic motivation, meaning that students, pupils, they will practice more, not less, there. But the environment has to be done in the right way. It cannot be too much game, but rather like at a certain level. Engagement goes up when you sort of inside the experience. Technology is a good amplifier for pedagogy if it's done right. And it's important to notice that this is not a replacement for a teacher, but rather a tool for learning. Inclusion matters. You have to design this in a good way. So many learning games I've seen over the years are sort of done very crudely. They're sort of very basic graphics, etc. And it's not really a game, but it's sort of, well, you have to put in the hours and time to actually develop the game itself. And this is the common thread across sort of 15 years of doing many projects in the gaming area is that sort of fun is not the opposite of learning. It's the sort of engine. And I just want to conclude with my vision for individualized learning as well, using AI assistance. This is something I wrote a paper on in 2014, where sort of I visualized on how the future of learning would look like, where we have a curriculum that is adapted to each student based on sort of using AI. It's multimodal. It's sort of we lose a bit of the sort of the class concept, but at the same time we can gather students together to discuss at certain points in their learning. And finally, also something that sort of comes from this whole generative AI area, and that is that we can create new learning materials, or we can take existing learning materials and switch that over in different media. So if we say we have text, we might have a digital book, we can convert that into animation, into games, podcasts, change language, we can change format of it, and sort of have this learning material continuously develop. We're not there yet today. We're getting some of these tools are coming now, especially Google is driving some of these tools where you can sort of get this sort of dynamic learning, but also coming at it from the programming perspective, where using like tools like OpenAI Codex or Claude programming, Claude Code, I mean, and you can create and computer programs that do much of this, but targeted towards just one single learning task. So we will sort of quite advanced environments that might be used for a short term, but then sort of help learning going forward. So with that, I wanted to conclude and thank you for listening. You'll find me on LinkedIn, Instagram, Facebook, and on my personal blog as well, where I've written a lot about learning with modern technology, especially with AI in the last years. Thank you for listening.